Okay, for 33, you're going to make a tree diagram. And we're going to have the probability that you're on time, which is, let's see, probably first flight leaves on time is 0.15. The probability of on-time complement is 0.85. The flight is on time. The probability that the luggage is okay. Probability that the luggage is there is 0.95. And this is the probability. Hold on. This is the probability that the luggage is where it's supposed to be, given that it's on time, which is 0.95. And the probability that the luggage is not in Chicago, given that it's on time, is 0.05. And here is, let's see, the first flight is delayed. Okay. So the probability that it's the luggage is where it's supposed to be, given that it's delayed, O complement, on-time complement, is 0.65. And the probability that the luggage is not in Chicago, given that the flight is delayed, is 0.35. So let's review this again. Probability it's on time is 0.15. The probability it's not on time is 0.85. The probability that the luggage is in Chicago, given that it's on time, is 0.95. Probability that the luggage is not in Chicago, given that it's on time, is 0.05. The probability that the luggage is in Chicago, given that it's not on time, is 0.65. Given the probability that the luggage is not in Chicago, given that it is not on time, is 0.35. So this tree diagram lays things out for us. Then, finally, we have our final probabilities. The probability that it's on time and the luggage is in Chicago is going to be 0.15 times 0.95. The probability that it's on time and the luggage is not in Chicago is 0.05. The probability that it's not on time and the luggage is in Chicago, this is 0.05 times 0.15, equals 0.85 times 0.65. And the probability that it doesn't leave on time and the luggage is not in Chicago equals 0.85 times 0.35. Okay. Now, let's see what we're being asked. What are the flight leaving on time and luggage making the connection events, making the connection independent events? Okay, so the flight leaving on time. If the probability of leaving on time is independent of the probability of the luggage being in Chicago, then the probability that the luggage is in Chicago equals the probability that the luggage is in Chicago, given that the flight left on time. Okay? All right. Now, how do we find that the probability is in Chicago? Well, we have 4 end branches on these probabilities. In how many of them do the probabilities end up in Chicago? 1, 2. So if you add these 2 probabilities together, you have the probability that the luggage is in Chicago. And then the probability that the luggage is in Chicago, given that it left on time. The probability that the luggage is in Chicago, given that it left on time, is this probability right here. Probability that the luggage is in Chicago, given that it left on time, is 0.95. Alright, so we add these two probabilities together. Hold on a second. So the probability that the luggage gets there on time is going to be 0.1425 plus 0.5525. Now, does that equal the probability? Does that equal 0.95? That's the probability that the luggage is on time, given that that the luggage is in Chicago, given that it left on time. Okay, that's this here, and that's 0.95. Are these two things equal? The answer is no. So they are not independent. Now this is 0.695. Okay. All right. So that's A. And then B for 33 is, what's the probability that the luggage arrives in Denver with her? Okay. Well, we figured that out. We added these two probabilities together. Okay. These four probabilities all add up to 1. Here's the probability that it doesn't arrive on time. And here's the other probability that it does arrive on time. And here's the two probabilities that it does arrive on time. Add these together, and you have the probability that the luggage makes a connecting flight in Chicago and ends up in Denver. So B is 0.695. Same number we just calculated here.